Hello students, I am Dr. Gajendra Purohit. I upload videos for engineering mathematics B.Sc on my YouTube channel if you are preparing for any competitive exam. Where higher mathematics is asked, my channel is very helpful for you. So today I will explain about the concept of the CF and PI under the higher order differential equations. And I will explain also how do we find the complementary function in this concept. We'll discuss about 4 to 5 different cases here, and according to those given cases I'll explain about the methods we use. If any question is asked in the exam based on this, you can easily solve it. And I had uploaded first order and first degree and first order higher degree differential equations videos which you can watch through IIT-JAM. Let me tell you, I have already created a complete series on differential equations. You can watch that through the link in description. The video of CF and PI has received over 1.1 million views. It has been loved by many students. I am grateful for the support I get from you. Now I am going to explain the same concept, but this time I am going to slightly elaborate it, explaining it in a detailed manner. If any differential equation is given like this, it means higher order differential equation with constant coefficients, which means coefficients of the derivatives of the equation here should be constants, right? Now for example, let's say an equation is given like this, d4y by dx4 plus here you have 3 into d2y divided by it is dx square in the denominator and minus dy by dx plus y is equal to 0. You can see here that in this equation all the coefficients of the derivatives here are constant. So this is a constant coefficient differential equation. Now students, it's CF. The answer of this part is the CF. Now let's say e to the power x is given here. CF is the answer of this part. What will be the answer we get from this part? It will be PI. Then the final answer we will get will be CF and PI. First of all, I'll explain you what is the CF and what CF means. I'll explain you that with an example. Now let's get started. Suppose a differential equation is given like this. Let's write its symbolic form, which is in the form of dny and plus a1 d power n minus 1y plus a2 multiplied by d power n minus 2y. And thus we will get the last term of the series as an. Y is equal to 0, right? If you want, you can take y out. Wherever you see d, what do? I'll take dn plus a1 d to the power n minus 1 plus this is an and y here. We will take these terms out. Wherever we have d, we call it symbolic form here. Now what we do? We write the auxiliary equation. In the auxiliary equation, we will put m in place of d, m power n plus a1. M to the power n minus 1 in this way, an is equal to 0. This is the auxiliary equation, and note that I've put dash here. Note that it is here. In this way we get it's the auxiliary equation, right? Now what do we do in this one? What do we find from this auxiliary equation? We find the roots. Upon finding the roots, then here we will write its CF. I will take an example to explain. I'll take one case. After that I'll explain some concepts to you. Here if we have any differential equation where the roots are distinct, what is given, students? The roots of the question are given distinct roots. They are real roots and distinct roots. In that case, the roots we get, alpha 1, alpha 2, alpha 3, we get them in power. And what does this become? This becomes the answer. Let's take an example. Students, if we have this example here, d2y by dx square minus y is equal to 0, right? We know it will be m square minus 1. Wherever we have d, we will replace it with m. And you can write this in symbolic form. You can write it like this. Then wherever it is d, replace it with m. Now if we find the value of m, it is plus or minus 1. We get two roots. One is plus 1 and the other is minus 1. This is m1 and m2. This is alpha 1 and alpha 2. So the CF will be c1 into e to the power x, I mean alpha 1x. And value of alpha 1 is 1. And c2 e to the power minus alpha 2x. Alpha 2 power is minus. So this becomes minus. Now what does this mean? This means that this and this, these two are its solutions. For example, it is e to the power x. If I say that u is given equal to e to the power x, v is e to the power minus x. I'm just explaining the concept and you will notice this will satisfy it. Differentiate it twice, put it here. You can take this y1, y2, it is better. y1 will satisfy this equation. Let's check it by differentiating it. On differentiating it once, we will get e to the power x. And when you do it the second time, then you know this will also be the same. And when you will substitute the value of this term and this here, you will notice it's becoming 0. Similarly, we will once differentiate this y2 here, right? Then we know we will get the value as minus e to the power minus 1. When we differentiate it once more, it will be d2 by dx square and minus will become plus. Now we will put these two values here as well, it will satisfy. Both functions e to the power x and e to the power minus x are satisfying it. Its linear combination is our CF. So this is the linear combination, right? C1 with e to the power x and C2 with e to the power minus x. And suppose a third function also satisfies this, like e to the power 2x satisfies this equation. In that case, we get C3 e to the power 3x, right? You need to note that the functions that will satisfy the differential equation, multiply them by a constant and write it down. It is called as the complementary function and we represent it like this. It is a concept. But we don't need to do that much here. You just take any equation directly. Look here, what we will do. This will be d cube plus 6d square plus 11d plus 6 into y is equal to 0. Students, wherever we have d, we will put m there. So it will be m cube plus 6m square plus 11m plus 6 is equal to 0. You will notice that when you factorize it, then you will get the factors as m plus 1, m plus 2 and m plus 3, right? If you need to know how to factorize it, there is a short trick that I've uploaded on my new YouTube channel. You can watch through the iTab how we factorize these equations and what will be the value of m. It will be minus 1, minus 2 and minus 3. The CF that we will get will be C1 e power minus x plus C2 e to the power minus 2x plus C3 e to the power minus 3x. This will satisfy and this will also satisfy the equation. This means it is the answer, clear? Hence, in this way we solve it. Students, look at the next question. It has been given d to the power 4 plus 2d cube minus 3d square minus 4d plus 4. So now, replace d with m, it is m to the power 4. 2m cube minus 3m square minus 4m plus 4 is equal to 0. But let me tell you that whenever we get the repetitive roots, you can notice here the roots are repetitive, right? And for instance, we get an equation like m. We get its root as 2, 2, 3. Suppose if we get equation like this, in that case, what is CF? This rule states that in that case, the CF we have will be C1 plus C2x e to the power 2x plus C3 e to the power 3x. What will this become? This will be the CF. Suppose here 2 is repeating itself. M equals 2 is occurring thrice. In that case, what will be our CF? It will be C1 plus C2x plus C3x square. This will be e to the power 2x. Suppose if it was given minus 2 here, then it would have become minus 2x. I hope it is clear. So, students, when you factorize this, you can see here 1 satisfies this. So, if you want to, you can factorize it. If 1 satisfies this, you see m is equal to 1 is satisfying this equation. This means what will be m minus 1 is equal to 0. It will be its factor. So, now what will we do? M minus 1 will be written 4 times because this is a 4th degree. I will tell you one trick how to do it if you can't find the roots. If this is m to the power 4, then what will we do? We'll multiply this by m cube, m to the power 4. When m cube and minus 1 will multiply, we will get minus m cube. And we need plus 2 m cube here, which means we need plus 3 m cube here, right? Only then will we get it. This means it will be 3m. When we multiply this 3m square, when we multiply 3m square by minus 1, we get minus 3m square. And we already have this term, so this is not required. Here, this will become minus 4. This means this last factor is of no use. Students, you will see that this will become its factor. When we take m minus 1 common here, then at this point we will get m cube. Plus it will be 3m square minus 4. Upon checking, you will see m is equal to 1 is making this 0. When m is equal to 1 makes this 0. This means what do we get? M minus 1 will be another factor. Take m minus 1 outside. What do? We write m minus 1 3 times as it is cube. We will write it 3 times. I am explaining the method. What will we put here? You can notice we multiply this by m square, then m cube. If we multiply m square by minus 1, we get minus m square. But we need 3m square, so it should be 4m square. To solve it further. Now we will multiply this by minus 4m here. So this is minus 4m square. Sorry, plus 4m square is needed. Only then will we get 3m square. So multiply by 4m. The product of plus 4m and minus 1 is minus 4m. And minus 4m is not here. So what will we do? We will add 4. Plus 4m minus 4m cancels out. We are left with minus 4. Now look, we get m minus 1 common. Is that clear? What you can do here? Take this m minus 1 square common from bracket. Here it will be m square. Plus 4m plus 4 is equal to 0. Now if we will simplify this again, we know that this term will become m plus 2 whole to the power of 2. Now we will simplify it. And what will be its roots? Let me write it here. Right? Now tell me what are we getting as its roots? To find the roots, we will find the value of m. Its value is 1, 1. And it is 2 and 2. So the CF that we get will be y is equal to, wait, I think this is minus 2. So the CF we get will be C1. And plus C2x e to the power x plus. Here you can see it is C3 plus C4 x e to the power. Minus 2x will be there. So students, what will we get? It will be CF, and that's how we solve it. Now we will discuss what do we do whenever we have complex roots. If equation is given with its roots as plus or minus 3 iota. So the real part is written in the power of e and the imaginary part is written in angle cos 3x plus C2 sin 3x. This will be the pi and this is given here, that we will get the alpha in the power of e and the beta will be in the angle, right? Now let me discuss this. You will see it is m square plus 1 is equal to 0. On simplifying it, we get m is equal to plus or minus iota. Its real part is 0, right? If the real part is 0, then it's CF. What will we get here? It will be e to the power 0x. This will be C1 and this is 1 only, right? And it will be x plus, it is C2 sin x. So what will we get here? We will get the CF. In this way, we solve it. Similarly, when we talk about this question, you can see it is m square minus 2m plus 5. It is whole square and it is equal to 0. Now we will find the roots. Clear? We know how do we find the value of m minus b plus minus, because we are not getting the factors directly here. Students, so when we are given any equation like am square plus bm plus c equals to 0, what we will obtain as the value of m? We know it will be minus b. What will come here? It is plus minus root of b square minus 4ac upon 2a. We will use the formula. B's value is minus 2, so it will be plus. 2 and plus minus, b square, this will be 4 and minus. What will come here? B square minus 4ac. So this will become 20. And it is divided by 2. As you know, a is 1, b is minus 2 and c is 5, right? When you solve this, you will get 2 plus minus. The value of this will be minus 16. This means we will get plus minus 4 iota divided by 2. When we simplify it, we get 1 plus minus. We will get 2 iota, but you can see it is whole square. So note that the root here will repeat. Whenever it is square, in that case, the roots will repeat. Now we'll write its CF. So what will we get as CF? As we have repeated roots, right? So y is equal to e to the power x, which is a real part. And here C1 plus C2x, then it will be cos 2x plus C3 plus C4x, and then it will be sin 2x. What is this value here? It's CF. So whenever we have an equation, this way we find its CF. Clear? Now observe the next case. If we get the roots as irrational numbers like alpha plus minus iota, or if we get the roots as beta type. So in that case, the alpha will come with the power of e, and the beta that will come will be cos hyperbolic and sin hyperbolic. Suppose if there's an iota, meaning it would be a complex root, then we don't get hyperbolic. In case of irrational roots, we get hyperbolic expression. So you need to keep this in mind. Now see another example. M square minus 4m plus 1 equals 0. You know the value of m will be 4 plus minus b square. We know this will be 16 minus. It will be 4ac. So we get 4 divided by 2. So here m is equal to 4 plus minus. Now you can see this will be 12. We can write this 12 as 4 into 3. So take out root 4, that is 2, it becomes root 3. It is to root 3. Now we will simplify it. So this will become 2 plus minus root 3, right? So now we know that this is an irrational root. In that case, its CF will be calculated. In some books, it will be written like C1 e to the power 2 plus root 3x and plus C2 e to the power 2 minus root 3x, right? Sometimes it is also written like this. And you can also write it like the formula I mentioned here. What will we get here? It will be e to the power 2x, right? And then this will be C1. And here it is cos hyperbolic root 3x. Plus it will be C2 sin hyperbolic root 3x, right? We will get this value. And you can write in any of the form. We will get the same answer on simplifying. In this way, you can find the roots, meaning it's CF. Now let's take a look at this question that you have to solve and answer in the comment box. Students, here you have to figure out what will be the CF of this equation. It's very simple. You have to use the same concept and solve it. Make sure to share your answer in the comment box along with the time it took you to solve it. Students, you can find more videos like this in the playlist here, in which I am again uploading the videos. And these are the updated videos with better content you can watch from here. You can also watch my old playlist of differential equations from here. I'm uploading a lot of tricks on my new channel. You can watch the videos from here. Subscribe to this channel. You can follow me on Instagram. Thank you so much for watching. Like it, share it and subscribe to the channel. Please give the answer in the comment box. Goodbye.